welcome back to my math teaching online today. In the previous video, I have shown you on the rules of derivatives, power rules, product rules, and chain rule and quotient rules. So today in this video, I would like to continue to show you how we can use them in an efficient way. So today in this video, we will use some of the combination of some of the rules together, mix them up between them, and use these rules to differentiate any function. So let's take a look at the first question on the board. Let me get right into it now. So on the board, I have brackets multiplied together. So the first bracket times with the second bracket. Now, this is the function y. And when we have a two bracket multiplied together, we can use the product rules in the derivatives. However, sometimes in the process of doing derivative, depend on the function, whether it's simple or complicated. Sometimes if it's so complicated, you want to simplify it first before you take derivative. Or sometimes you can just take derivative first and simplify it later. So none of the questions are the same. Depend on the question, and we try to do it in a seamless way as much as we can. So I want to show you how we can do this question in two ways, right? The first way and the second way, and it's up to your preference. You can decide it which way is work better for you. And sometimes we form a habit of doing it. If we form a habit from a shortcut, then we do things in the short way. But if you do in a long way, if you do correctly, eventually you still get the same answer. And that is the beautiful about math. Doesn't matter what way we do, we still end up with the same answer. And sometimes we might use both of them to check. If we don't have answer key provided from the textbook, we can just using different way and say, oh, on the way we did, it's come up with one answer. So it's more confident to believe that we did it right. Anyway, let me get right into the question right now. So I am going to, first way, I'm going to use the product rule first. So I'm going to use the product rule. Hope you can see it, not very so clear, right? So I'm going to have to do another, sorry. Okay, so how do we do product rule? We're going to, the product rule say that whenever we have a two bracket multiplied together, we can keep one of them the same, derivative of the second one, or keep the derivative second one and keep the other one the same. Then adding with derivative of the other one. So the order doesn't matter. Some people will check derivative the second bracket first and then keep this the same. In my way, I tend to keep the first bracket, but it doesn't matter in the order, right? As long as you keep the first one, derivative second one, adding with keep the second one, derivative of the first one. So that will be the product rule. So in my way, I'm going to keep the first bracket the same, 6x to the power 4 minus 3x squared plus 1. Now I'm going to derivative of the second bracket. So derivative of 2 is 0, minus x to the power 3 become minus 3x squared. So now I keep the first one. Now I'm going to add in with the second one. Now I change alternative, right? So we already keep the first one. Now we keep the second one the same. So 2 minus x to the power 3, nothing change. Now derivative of this one will be 24 x to the power 3 minus 6x plus 0, but we don't have to put 0. So now and this is the derivative function, right? So now let's simplify it because it looked very complicated. So I'm going to time this with this, and time this with this, and time this with this. Distribution, right? So that would be minus 18 x to power 6, adding with 9x to power 4, and minus 3x squared. Now I'm going to distribute this bracket down here, right? So add 2 times 24 will be 48 x to power 3, and 2 times this minus 6 minus 12x. So I'm done with 2. Now go to next one, will be minus 24 x to power 3 at 3 is 6, and minus is adding, adding 6 x to power 4, right? Yeah. So minus times minus is add 6x to power 4. So now let add this, simplify this polynomial one more time, and this still our quadrant, right? So I have minus 60, 18x to power 6, and these terms are the same, so I'm going to add them together, and this will be 42, right? 12, yeah, minus 42 x to power 6, right? This equal minus 42 x to power 6, 9x to power 4, adding with 6x to power 4 will be plus 15x to power 4. So we're done with this, Now this one is minus, this is plus. So I'm going to say 48x to power 3 minus 3x squared, and the last term minus 12x. So they are non-like term anymore. We cannot add them anymore. This is our answer. So let's get right into the second way how we do this. Now in the second way, instead of taking derivative using the product rule, I'm going to multiply these two functions together. It's like expanding them, tie them together first, and that's still a y function, right? So I leave the derivative. I'm going to tie them together first. So second way, I will say y equal 2 times 6 is 12 x to power 4. 2 times minus 3 is minus 6x squared. 2 times 1 is plus 2. Now x to power 3 times that will be minus 6x to power 7. Minus times minus is adding 3x to power 5, and adding with, no, minus with x to power 3, right? So when I multiply these two brackets, this is what I got. Now I'm going to take derivative, right? So now I use the power rule. So after I simplify them, I expand them, now I use the power rule instead of the product rule, right? So 4 times, this is 42 x to power 3, 48, sorry, 48 x to power 3 minus 12 x to power 1 plus 0 minus 42 x to power 6 plus 15 x to power 4 minus 3x to power 2. Okay, so this is our answer. Now let's check the answer. Are they the same? 48x to power 3, 48x to power 3, correct? Same thing. Plus 15x4, plus 15x4, plus 15x4, so the same. Minus 3x squared, minus 3x squared, same. Minus 12x, minus 12x, minus 12x. Same. minus 42x to the power 6 minus 42x to the power 6 minus 42x to the power 6. So you see that we end up with, whether we do the first way or second way, we end up the same answer. So yes, they are the same answer, right? Same answer. So that's the two way of doing it. Now let's get into the next question. The next question I want to show you is 2x plus 3, all of them to power 3 on top, divided by square root of 4x minus 7. So this is a little bit complicated, right? But let's see how we do it. And of course, this function is a y function. Now we're going to do derivative of this one. So this is the quotient rule, right? And if we do the quotient rule, I'm going to change this in terms of 2x plus 3 to power 3, all of this over 4x minus 7. But I'm going to change the radical and become a rational function, which is 1 over 2, so that I do it more easily, okay? So y prime will be equal, the quotient rule say I'm going to keep this one the same, so I'm going to keep this the same, 4x minus 7 to 1/2. So keep this one, derivative this one. Derivative this one is 3 times with inside exactly the same. And all of this outside will reduce by one level, right? That's square. Now, we're not done yet because remember, when we derivative this one, we got a composite function. So we bring the first derivative down, we change, become 2, everything inside the same. However, we have to derivative the inner function. So with this, we call it chain rule, right? So this is a combination of quotient rule and chain rule. So now we derive the inner here is times 2, right? Derivative 2x is 2. So we're done. So we keep the bottom the same. We derivative this one. Now we subtract. Now we keep this the same. 2x plus 3 is the same, power 3. Now we do derivative this one. Derivative this one is 1/2. We bring it down. Time with everything here is the same. 4x minus 7. So 1/2 we bring it down. Time with 4x minus 7 minus 1/2. We subtract power 1 on top. So become minus 1/2. So bring it down. Subtract that. Now, derivative of inner function chain rule is times 4, right? So we're done. Now, all of this we divide by 4x minus 7, 1/2 to all of them to power 2. Now, this 2 will cancel with the 2 down here. So we left with just 4x minus 7 to power 1, right? Just leave it for now. So y prime will be equal, I'm going to simplify this complicated function, right? Now, let's see how we simplify this. This 2 can be timed with this, right? And become 6. So I'm going to change this become 6, right? And you know what? Let's do it next step so that you don't confuse with it. Okay. So this, I'm going to, you know what I'm going to take care of the common factor first. Okay. And the common factor I can see for the left of this long expression and the right between them is a negative, right? So the common factor in here is 4x minus 7 to the power minus 1/2. So I'm going to take this one as a common factor. Also, 2x plus 3 to the power square as the common factor. Because when we pull out the common factor, we have to choose the least power, right? So there are two common factors going on in here, this expression and this expression. But I'm going to choose the least power, right? So pull out the common factor, we have 4x minus 7 and minus 1/2 times with 2x plus 3 and power 2. Inside, we'll open the bracket. We multiply with the 3 and the 2 here, right? For the left one, for the left part, 3 times 2 is 6. So I'm going to put 6. And we have 4x minus 7 to the power 1/2. But here we have minus 1/2. So we have to time with another 4x minus 7 to power 1. So that when we multiply them, we add the power, it become positive 1/2 like that, right? So that's we done with the left side of the expression. You see the middle one, right? This is the arrow. So I'm going to put down this one again, minus. Now let's check this. We have 2x plus 3 power 3, but here we have power 2. So we have time with 2x plus 3 one more. And we have minus 1/2, which is the same like this one, so we don't have to do anything with this. Now we have 1/2 times 4. 1/2 times 4 is 2, right? So we time with 2. Okay. 2x plus 3 to power 1. Yeah, 3. Okay. So now, all of this will be over 4x minus 7 to power 1. So because this and this now look the same, so what I'm doing, I'm going to bring this down here, right? So I'm not doing anything. I just bring this down and I can do that, right? Because you see minus 1/2. When I bring it down, it becomes positive 1/2. So I'm going to bring it down, 4x minus 7, positive 1/2. Now they're exactly the same, but this is 1/2 at 1. We can simplify it later. So this is gone when I bring it down here. Okay, so here I will have 2x plus 3 on of this, the power square. Inside, I'm going to simplify this a little bit. 6 times 4 is 24x minus 6 times 7 is 42. And then minus, right, this minus, I'm going to time this with this, is 4x, and time this with this is minus 6, because this negative make it become negative, right? 2 times 3 is 6. All of this will be over 4x minus 7. Power 1/2 at power 1 is power 3/2, right? So now, let's simplify one more. We have 2x plus 3 on of this, the power square, time with inside, we have 24x minus 4x is 20x. So that's gone, that's gone. Minus 42 minus 6 minus 48. All of them over 4x minus 7 to power 3 over 2. Okay, is there anything else we can simplify further? I think that's it. This is the seamless form it needs already. We also can expand this bracket, right? And then tie them together and add them, but we don't have to if it's so complicated. As long as we get the correct derivative, then everything should be okay. Okay, so this is the quotient rule and the chain rule together. This is the product rule and the power rule together. I am introduce you today in this lesson. So I hope that you enjoy this video and stay tuned for our next video. So give me a thumb up if you like my video on YouTube and hit like button. Thank you. Bye for now.